Okay, hello everyone. Today I'd like to tell you that game studies could benefit from theories of embodied cognition when thinking about players in specific. I'll give you an overview of what embodied cognition is and how it applies to players. I'm Jonne Arjoranta. I'm a PhD student from the University of Jyväskylä and finishing my studies there. And I'm studying how games create meaning and how they are interpreted by players. I started thinking about embodied cognition when I spent half a year in Denmark learning about that, and I think this is part of what I took from that time. Some examples, this is going to be very simplistic even, and I'm not trying to talk down to you. I just want to keep it simple so I can follow up where we are going, and those of you who don't know what embodied cognition is can kind of catch up. So if you have corrections for me, I'm happy to hear them. First, I'll tell you where embodied cognition comes from and give you a somewhat loose definition of what embodied cognition actually is. Second, we're going to look at some examples of experiments that show certain kind of embodied cognition going on. And these are used to give you an idea of what embodied cognition actually is and how it affects our being in the world. There are 3 examples, with the last one being most relevant to our topic, games. Then we're going to move on to games. We'll look at 2 specific examples of how embodiment might affect our interactions with games and how one might take embodiment into account when designing interfaces. Let's first look at the background and where the theory comes from. First of all, it's known by a couple of names. It's embodied cognition, embodied mind thesis, also discussed in similar related theories like situated cognition. It is studied, for example, in cognitive and social psychology, cognitive linguistics, and neuroscience. Please notice that I'm limiting the discussion to examples that are relatively modern and from a certain tradition. There have been earlier researchers that have looked into this, like the phenomenological tradition, Heidegger, Merleau-Ponty, that kind of stuff. That's relevant, but we're not going to discuss that today, at least in this talk. And there's also been games researchers who've taken embodied cognition into account. Probably most relevant of those, or most thorough of those, has been G's 2008 paper. What connects the modern strands of embodied cognition together is the thesis that the nature of our mind is somehow determined by our bodies. There are stronger and weaker versions of this claim with varying amounts of evidence between them. Different researchers connect slightly different arguments to this thesis, but commonly these 6 are mentioned. First, that cognition is situated. Second, that cognition is time pressured, that we offload cognitive work onto the environment, that environment is somehow part of the cognitive system, that cognition is meant mostly for action, and that offline cognition is based on our bodies. These come from Wilson's 2002 review paper. I'm not going to go through all of them in detail, but you can see how they fit together to form some of the central ideas of embodied cognition. You should also note that not all of them are equally rooted in experimental evidence. Wilson finds the 4th one most suspect, and the 6th probably the strongest. Next, let's look at some examples of how embodiment affects our cognition in practice. Our first example comes from a 2002 paper by Swan, Stanfield, and Huxley. You can check their paper for more details. I'll go through this quickly. They presented the participants with pictures of animals or objects, so that each participant had a pair, another participant, who was shown a different shape of the same object. Examples included pictures of an eagle with either wings outstretched or wings drawn in. Or the one you see here, pictures of an egg in a carton or just plainly an egg in a pan, frying. They presented subject with experimental sentences like the ranger saw the eagle in the sky, and noted that whenever the picture matched the orientation in the sentence, wings outstretched here, subjects were faster to recognize the objects correctly. They argued that this experiment shows that that instead of amodally storing linguistic information of eagles and eggs, subjects used perceptual simulation as part of accessing that linguistic information. Or to put it in other terms, they had a perceptual image of the object while figuring out what the word refers to. This is called cross-domain mapping, where linguistic activation primes perceptual activation or vice versa, and is one of the ways that show how linguistic processing is based on bodily processes, here perception. This will prove informative later when we discuss games. But now let's look at the next example by Boroditsky and Ramskar, also from 2002. They first primed their test subjects with one of the pictures you see on the slide. The subjects were asked to draw an arrow showing how they maneuvered the chair towards the X. So depending on which picture they got, they did it either by moving themselves, if they sat on the chair, or by moving the chair towards themselves, pulling the string. They were then asked the ambiguous question: next Wednesday's meeting has been moved forward 2 days. What day is the meeting now that it has been rescheduled? And they answered either Friday or Monday, depending on how they understood the question. And as you might already guess, there was a significant priming effect from the slide they just saw. So they were primed for either the ego moving perspective, Friday, they moved themselves, or the time moving perspective, the time moved to Monday. In other words, and this is the important part for us, the subjects used their conception of space to think about time. And now let's move on to the third example, which is most directly relevant to the topic we get to in a bit. The third example is from Antle, Cornes and Jumeva from 2009. It was an experiment to see how embodied metaphors would help in understanding an augmented user interface. They built a system you can see on the slide for interacting with sound by moving in space. You can see in the picture how it technically works, but of particular interest to us are the space where the movement happens around the camera and where the parameters are mapped. The thing they were testing was how different parameters affect how people learn to use the system. So they had two versions. One based on embodied approach, where the parameters were mapped to embodied metaphors, and a non-embodied version where the parameters were not corresponding to the embodied metaphors. You can see examples here. when given a short time to learn the system and then given tasks to perform, there was a significant difference in how well the different groups did in the experiment, how well they learned to perform the tasks correctly. The ones using the system with embodied metaphors correctly performed 80% of the tasks, while the ones using the non-metaphorical mappings only managed to succeed in 20% of the tasks. Quite a big difference there. Now, you might look at this slide and think that that's not so surprising, that the mappings listed as metaphorical and are intuitive, easy to learn, and the ones listed as non-metaphorical are non-intuitive, hard, etc. And you'd be right in thinking so, because that's exactly the point they were trying to go after with this experiment. Exactly the point for metaphorical mappings. They are intuitive, easy, and easy to learn because they rely on our embodied experiences, or our experiences of beings as people with bodies. Designing good interfaces, and I use this term very broadly now as ways of interaction, can be done with embodied experiences to make systems more intuitive for their users. You should now have an idea of what we talk about when we talk about embodied cognition. I'll now move on to present examples of using this framework to understand players and how they understand spatiality and interfaces. If we first discuss interfaces and how they affect players' experience of spatiality, Ego and Sullivan are unfortunately a good starting point. Regardless of how large the game is from the inside, from the outside, its interface, it's still a small set of ways for the player to interact with it. Usually and traditionally, these ways of interaction have been limited to a few standard forms of interaction. In the example of the keyboard, it's a tool not designed for games, but for typing. It's a metaphoric extension of the typewriter, with all the possibilities and limitations that come with that. However good the simulation of an avatar's body is within the game, it is still interacted with through these series of button presses or mouse clicks. The system's understanding of the player's body is still the finger, eye, ear hybrid you can see on the slide. Well, the most obvious way of improving the situation is to expand the system's understanding of what the player's body is like. This can be accomplished by, for example, the Microsoft Kinect system that is mapping the player's body on this slide. As you can see from the slide, the system's understanding of the player's body is already much better than what it used to be with the keyboard and the mouse. Here the player's body is mapped on the wireframe that the game can understand, and actual movement in physical space is mapped on the movement in digital space, bringing it much closer to what the interface was like with Andal, Cornice and Drumeva. But designers don't need to be working with systems like Kinect to take our embodiment into account. It can be also done with systems not as aware of our bodies as Kinect. Let's take a look at the first example. Elder Scrolls V Skyrim. All player characters in Skyrim are right-handed. This means that by default they wield any weapons they find in their right hand. When playing Skyrim with a mouse and a keyboard, the game defaults to controls inherited from other first-person games, mostly first-person shooters. which means that the left mouse button is used for attacking with the right hand, and the right mouse button is used for blocking and spellcasting with the left hand. Essentially, this means that the left mouse button controls the right hand and vice versa. Later in Skyrim, it becomes possible to use both hands for spellcasting if you make a spellcaster. Still, the left hand is the default used for casting spells, so the additional second hand is used by the default attack button, the left mouse button. So the character holds both hands up when ready for spellcasting. You can see them on the screen. But when you click the button on the corresponding side, the opposite hand moves. It's kind of opposite way around. You can see a similar situation in Borderlands 2, where one of the characters is able to draw a second gun and shoot with both hands at the same time. But in this case, the designers saw that this might be problematic for some players, figuring out the kind of reverse correspondence. So they added the option that when you draw double guns, the mouse button switch places. So the left one controls the left hand, and the right one controls the right hand. Another simple example of how to handle this situation better would be to look at how the controls are laid out in the Xbox version of the game Dishonored. The controls are laid out so that the actions on the left hand are controlled with the triggers on the left, and actions on the right hand are controlled with the triggers on the right. Again, you can see both hands on the screen. Here, you can almost see them on the screen. If the picture was better, you'd see them better. But here you are reminded of what the hands do. Right one is for attacking, there's a blade in it, and the left one is for spellcasting. And this time there's a correspondence with the buttons that control those hands. This is, I admit, almost trivially simple, but compared to playing the same game with a mouse and a keyboard, it's more intuitive because of the correspondence and our experiences of handedness, left and right hand side. Now, in conclusion, we can recap what game studies can learn from the theory of embodied cognition. Let's return to the first two examples discussed about priming. Let's take a minute to think about how simple priming effects could be used to help the players reach the interpretations and choices meant by the designers. Cross-domain mapping could be used either for linguistic to spatial processing or vice versa. For example, to guide the players through some area or highlight some parts of it. And note how the information itself does not need to change. Only the way it's presented, just like the experience discussed here. And if we acknowledge that players are being affected by their embodiment, we can move on to discuss how that is happening and how we might use that knowledge to better design game experiences or think about them. It may be through priming effects or better acknowledging how we humans are used to interacting with the world through our bodies. In closing, we can think for a moment of what kind of research on embodied cognition we could see in the future. First of all, we might hope to see research into what would be the effects of embodied cognition specific to games, or especially prominent in games. But we can also expect to see studies in cognitive science that use games as part of the experimental setup. This has happened before, often, and is likely to happen again, so we might as well look. And I'm certainly not surprised by this, because if our cognition indeed is situated, time-pressured, body-based, action-oriented, and done in conjunction with the environment we are in, it's very suitable for dealing with the kinds of problems games present. Now, if you have any comments or questions, I'll be happy to hear them. Thank you.
Thank you. Do you know the game Pew 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 Pew? It's an experimental game.
I'm not sure. No.
So this is a game in which players try to navigate a little guy with a jetpack and a gun through a rapidly moving asteroid field. And two players have to play it together. And their control scheme is each of them gets a microphone. And the person who controls the gun controls it by saying pew, 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 pew. And the person that controls the rocket controls it by going and apparently much of the challenge is controlling your breathing and trying to control your wild laughter, which tends to kill people. And it strikes me that in this case, the pleasure of the game is that it runs against embodied cognition. Same with this game I was addicted to called Psycho Pong, where the Pong board spins and your directional controls suddenly remap up and down. And I wondered if you thought that intuitively built controls were always better, because it seemed like some of these games, the pleasure is fighting really unintuitive cognition and learning some alternative, like some of the stuff you were talking about, like an alternative cognitive possibility or something like that. Sorry, that's vague.
No, I definitely agree with you. If the second point was that if we take embodied cognition into account, we can kind of become aware of it and maybe use it in ways that we are not used to. So we could make games that take our expectations of embodiment and run contrary to them, just like the example you gave. That would also lead to fun gameplay, because we need to learn new skills, not based on the ones we've used to.
Yeah, just in addition to that, I think that the testing more applied to how people got introduced to games or how they learn the game mechanics. So that's the mapping of the body schema. And if in these examples with reverse control, has there any testing been done, or do you think that's fruitful to do any testing? What would that mean for our body schema outside of games? If we inverse all the controls, and would that mean something for back? Is there another mapping on the outside world then going on? Or
I'm not sure.
You could test that, right?
You could. I'm not sure what kind of information you would get out of that, because you would first need to figure out what the kind of the embodied expectations were, and then reverse those.
Okay, so you think they are given anyway? So the body schema is like given for all.
It is more or less standard. At least that's the argument. It's not rock solid though.
No, it was interesting your talk and your conclusions, the possible future directions. But I think if you go and look at research, there's quite a lot of research now on the effect of learning in games, learning effects in games, especially in educational, serious games, kind of that field there. I think you find quite a lot of research that is now taking seriously this idea of embodied cognition. I mean, people like James Paul G, for example, and Henry Jenkins have been, talking about this. That the embodied experience is something which, is really important for taking into account. So you probably find support for your
yes,
stuff.
G 2008 was one of the papers I cited. I definitely agree, and we could possibly move that outside the games for education field, where it's kind of its own thing.
Oh, there was one other thing I forgot to mention as well. I don't know if you've seen Janet Murray's last book on interaction design. I mean, she's been working with games for years, and now she produced this enormous tome with the MIT Press, where she's talking a lot about player agency and the importance of designers taking the need to create player agency, sense of agency, embodied agency when they're playing games. You might find that, if you haven't looked at it, it's quite an interesting book, actually.
Thank you.
Okay, thank you, Jonne. And now it's 15 minutes coffee break.